That is why I'm going to make a group of 0 and 2. Then 0 and 8. 0 is from first group, 8 is from second group. So that here also only one bit is going to be different. That is why I'm going to make a group of 0 and 8. So likewise it goes on. Group 1 to 2, then group 2 to 3. So from group 2 to 3, I will get all these things. And from group 3 to 4, I will get these number of minterms. Now, after this, again repeating the same thing, step 2, group 1 to group 2. Compare the group 1 with the group 2 and find out only one different single bit. Okay. So after comparison of this group 1 to group 2, what we have got? This 0 to 8 10, 0 8 to 10, 0 to 8 10, and 0 8 to 10. These are having a similar things, but only one bit is going to be different. That is why we are going to make a group of that minterms. Then group 2 to group 3, I have got this 2367, 2637. Now we were at this point. Let us go for the step 4 now. So now in step 4, what I can get is, now if I compare everything, I will not get anything. So what I'm going to do is, the bits minterms are equivalent here. See, 0 to 8 10 and 0 8 to 10. Both are going to be same, are having same values, minus 0, minus 0. Here also minus 0, minus 0. So what I will do is, I will merge 0 8 to 10 and 0 to 8 10, and I will write only one minterm here, one group of minterm, 0 to 8 10, minus 0, minus 0. Then in group 2, again I have two groups here. So here also both are same, minterms are ordered differently. So here also I am going to merge these two. So I will write 0 minus 1 minus 2 3 6 7. I will consider only one group. So now here what I have got is, I have got two groups. So from these two groups I will get, because further I cannot reduce it. That is why I will get two prime implicants here. So what are those two prime implicants? From group 1, I will get x bar and z bar. This one. So what I am getting here, it is x is 0, z is 0, there is no y, there is no w. So here from this x bar and here it is z bar. This is what minterm I am getting. This is called as a prime implicant. Prime implicant. Okay. And from this group 2, what I am getting? I am getting w bar and y, w bar and y. So this is one more prime implicant. Okay, this is one more prime implicant. So two prime implicants I have got, two minterms I have got from the above problem. Okay, and what are the uh, essential prime implicants from this? That is, let us find out, determine the essential prime implicants. So what actually my problem is, I have these many number of minterms, 0 2 3 6 7 8 10 12 13. So out of this, the x bar and z bar, that is from the first group, what I have got from the first group, x bar and z bar. So from this group, what I have got, 2, 0, 8, 10. 2, 0, 8, 10. So what I will do is 2, 0 or 0 to 8, 10. I'm writing 1 wherever I have these min terms 0 to 8, 10, which are covered by x bar and z bar, which are covered by x bar and z bar. So now from this, I'm just writing 1 wherever I have a min term 0 to 8, 10. So there I'm writing 1 and 1, 1 and 1. Then from the second prime implicant, from the second prime implicant, what are the values I have? 2, 3, 6, 7. 2, 3, 6, 7. That is, wherever 2 is there, there I am writing 1, 3 as a 1, 6 as a 1, 7 as a 1. So now here, from this prime implicant, x bar and z bar, x bar and z bar, from this prime implicant, what are all the number of ones which are not covered by other prime implicant? What are the minterms which are not covered by other prime implicant? So there are only two prime implicants are there, x bar z bar and w bar y. So from this, which are the minterm? Zero is a minterm. Whether the zero is covered by some other prime implicant? No. So this is going to be the essential prime implicant. The minterm 0 is essential prime implicant. Let us see whether the 2 is covered by some other prime implicant. Yes, the 2 from x bar z bar is also covered by w bar y. That is why the 2 is not an essential prime implicant. So after 0, which is another prime implicant? 8. Let us see 8. Whether the 8 is covered by some other prime implicant? No. Whether the 10 is covered by some other prime implicant? No. So 8 and 10, these are essential prime implicants. These are essential prime implicants. Okay. Now let us check from this w bar and y. W bar and y, which are the essential prime implicants into this prime implicant? Whether the one is already that is the minterm 2, which is having 1, is already covered by x bar z bar. So this will not be an essential prime implicant. Except this, there is 3, 6 and 7, which are not covered by any other prime implicant. So 3, 6 and 7 are also essential prime implicants. Have you understood this? It is so simple that first thing ascending order, second thing comparison, third thing is also comparison, fourth thing is also comparison if it is possible, or else fourth step is merging, whichever the same values are having, merge them. And then fifth step is determining essential prime implicants. Okay, so in the fourth step only we will get here, in the fourth step only we will get which are the prime implicants, like this: the x bar, z bar, w bar, y. These are two essential, two prime implicants. So from this, in the step 5, I will come to know what are all the essential prime implicants. So hopefully this is up to the Quinn McCluskey first module. After this, we will go for and even I will share some notes in the WhatsApp group or wherever in the portal, students portal. Okay, SIT student portal. You just find out all the notes and go through many number of uh, problems are there. Okay, you go through all the problems, practice all the problems. If you find any difficulties, you ask me. Okay, so after this, now i I feel we need to move on to the second module. Okay, in the next class we will start the second module. So today it is enough. I think we have completed the this example 023678101213. Okay, fine. uh, is it understood? Reply in the chat box. Anyone? Akshata Ukuli, Muskan Sheikh. Yeah, Sumaya, Jiha Sheikh. Yes, sir. Okay, fine. Thank you. Thank you. Right. So we'll close the session now. Tomorrow we'll be beginning with second module.